Hello, physical scientists. Ms. Getz here. Today, I'm going to walk you through investigating our air quality investigation tool and how to use it to make claims about the effect of combustion and its effect on air pollution here in Minnesota. So we're going to start out by opening up the air quality investigation tool. And when you get here, what you'll notice is that we have a map here, and you can tap on the different points on the map and see what they're called. Voyageurs National Park. We've got Boundary Waters. It's also part of a big park. We can look at the Tallahassee School here in St. Cloud, or we can zoom in and look and see what sites we have here in the Twin Cities. So in downtown St. Paul, we have the Ramsey Health Center. And on the east side, we have Harding High School. We can look at some sites in Minneapolis, like the Anderson School, or in the surrounding metro, the Anoka County Airport, the town of Apple Valley. And you'll notice that there are some other sites that are listed that you might recognize some of the names of here in the Twin Cities. So we have a bunch of different tabs that we can investigate, and today we're just going to look at the seasonal tab. So here in the seasonal tab, it automatically generates this first sample plot for you. And it says average PM 2.5, so that's the particulate matter 2.5, the air pollution of that size, across seasons in 2015. And I'm actually going to switch to looking at 2019 because that's a little bit more recent, a little closer to now. You can use whatever year you'd like when you do your investigation next week. But looking at this, I can see that there's this interesting pattern going on. In blue, we've got Ramsey Health Center, and in red, we've got Harding High School. So I can tap on the points and actually see what the reading is. And we can see Ramsey and Harding follow a similar pattern, and in winter, there's a pretty big difference, but the other seasons, they don't seem to be too different. We can look at different locations. So we could say, oh, well, what about near Road I-35? Another similar pattern. We can go, well, what about a different city? What if we look at the University of Minnesota in the city of Duluth? So that's pretty similar in the fall and winter, but then Duluth has lower air pollution in the spring. Interesting. It's kind of weird. What about someplace far away? So if we go to the Boundary Waters, so you could click on any of these, but I'm going to click on the Boundary Waters. And I notice, again, Boundary Waters is in red, and it has, in general, a much lower air pollution than Harding High School does here in blue. And so I think this is pretty interesting. So I'm going to grab a screenshot, and you don't have to because I did it for you, and put this into my CER worksheet. So here in my CER worksheet, we're going to start off by doing what I just did. You don't have to do it right now because you just did it with me. But I've spent a little bit exploring the tabs and site locations and years in our air quality investigation tool. Notably, for some of the tabs, especially the, I think, holidays tab and human impact tab, takes a while to load sometimes. And sometimes someplace that you might look at doesn't always have data. So like if I click on, I believe there's Payne Phelan doesn't have data here, so we just see Harding High School. So that's something that can happen. And if you encounter something that doesn't have data, maybe try switching the year or just picking a different site, a different location that does have data in that year. So what I'm going to do here on my worksheet is I'm going to write down some stuff I noticed, just so that you can take a moment to think about some interesting things. So for example, I noticed that air pollution at Ramsey Health is similar to Harding in the seasonal tab. So notice I'm using this sentence stem. I saw that air pollution in Ramsey Health is similar to Harding in the year 2019 in the seasonal tab. It's really helpful to jot down what tab it is because it's easy to get a little bit lost if you find something interesting and want to find it again. I saw Duluth had similar air pollution to Harding in 2019, but Harding's was higher sometimes in the seasonal tab. And I also saw that the Boundary Waters had lower air pollution than Harding in 2019 and other years in the seasonal tab. And so I didn't show you exploring other years, but you can try that on your own and see if my claim is true, that it's also higher in other years besides 2019. So then what we're going to do is we're actually going to start writing our CER. So CER is a claim, evidence, reasoning, and it's an explanation of something in science or in everyday life or in another subject. So we start out by picking our evidence. And this applet has just tons of evidence. And so we're going to focus in on this last relationship, this last thing I noticed, that Boundary Waters has a lower air pollution than Harding does. And so I've gotten a screenshot of that data and I have dropped it in here and ta-da, there it is. And so you could, if you wanted to, have multiple screenshots. So maybe you want to compare these two locations using different tabs. You could do that as well. But we're just going to focus on this one for this week's CER example. Next week, you'll try making your own. Then we go to our second step, which says annotate your evidence with WIS-WIM statements. So that's what I see and what it means. So I'm going to start out with my overall what I see. Overall, the red line is always higher than the blue line. So you can add this in on your evidence document. So you can add in annotation, you can write right on top of it. And what that means is that Harding has higher air pollution, well, it should be ER, higher air pollution than the Boundary Waters. So overall, Harding is higher than the Boundary Waters. Then I'm going to go ahead and notice, oh, look, there's this funny peak. There's a peak in winter in red, and a smaller peak, there's still this peak here in blue. And so I want to think about what that is telling me about air pollution. What does that mean? So what it means is that air pollution increases in the wintertime. And then I might try to find something else to notice. I noticed that there's this little upward spike here. So what I see is that there is a small peak in the summer in red and a bigger peak in blue. So there's this little increase in red and there's a big increase in blue here in the summer. So what that means is that summer also has an increase in air pollution, but not as much as winter. So if you need to pause the video here and write down these WIS-WIM statements on yours, please go ahead and do so. And do try writing them out. So you can shorten your sentences if you want, but make sure you're still pointing out the same things you see and what they mean about air pollution. So then we're going to go forward. We've annotated our graph. That's our evidence. And we're going to make sense of our evidence. So I made sense of some of it for you. So what does your evidence show about air pollution? Well, over the seasons, there is less pollution in the Boundary Waters than in St. Paul. But both locations have the same pattern of change in air pollution because I noticed that both went up, down, back up. So it's the same pattern. And then we can think about, well, what other knowledge or evidence is going to help you with that? So Boundary Waters is up here, and St. Paul is right here. Harding High School is about right here on the map. And I bet that you know some big differences about those two. So St. Paul, where Harding is, has a lot more people than the Boundary Waters. Very, very few people live up in the Boundary Waters all the time. Whereas here in St. Paul, we have like a population of like 450,000 people in the immediate area here in St. Paul. It's a lot more people. You also probably know something that might explain this seasonal pattern. So can you think of any reason that there might be for there being more pollution in the wintertime and the summertime than the spring and the fall? Remember that most of this air pollution comes from combustion, from when we burn fossil fuels, and it releases particles into the air. And one thing that's really big and different is that people heat buildings in the wintertime and they have to cool them in the summertime. So that's another piece of evidence or knowledge that can help us make sense of this pattern. You could do some research and actually find some evidence, maybe the population of St. Paul and the population of this area of Minnesota where the Boundary Waters is. And that could be evidence that you actually have a citation for. But we're going to move forward this week, keeping it pretty simple. And we're going to move forward to writing some claims. And I actually wrote both of these claims for you. So I have our main claim, which is that air pollution is much higher in the city of St. Paul near Harding High School than it is in the Boundary Waters, a big park in northern Minnesota. And we have a bonus claim that air pollution goes up a lot in the winter and down in the spring and fall. So your claim is a one-sentence statement of what is happening based on our data. And we're going to then write down our reasoning and describe how our evidence supports this claim. That's step 5 here. And I have a variety of sentence frames, some of which we're going to use in our reasoning evidence paragraph right here. So we start out by describing our data. So I'm going to say what our data is. In the graph of, you can look back and see what the title of the graph is. It's PM 2.5 across seasons in 2019, comparing Harding High School in red and the Boundary Waters in blue. I can see big differences between the two locations. Harding High School has a much higher air pollution during all seasons than the Boundary Waters has. This is because, so we're going to say why we think that is, the Boundary Waters is a rural area where few people live, and Harding is located in St. Paul where lots of people live. So this is why we think there's this difference, why we think this is happening. I know that people often create air pollution. We make it. So it makes sense that an area without many people living there wouldn't have as much air pollution. Harding High School has significantly more air pollution than the Boundary Waters because of the different populations of the two areas. So notice that in my reasoning paragraph here, where I'm restating my evidence and I'm connecting it to my claim, I describe the evidence that we found, including what the graph is called, what the graph is showing, and what we saw, much higher air pollution, what it means on the graph. Then I went into why I think that is happening. So this is because this is what you think is happening. Why is this pattern here? And then I connected it to what I know about air pollution is that it's generated by people. So if you don't have very many people, you won't have as much air pollution. And then the very last thing is that our last sentence restates our claim. And so I'm restating my claim here in this last sentence. So hopefully this helped you think through using this data like a biostatistician would to make claims about its effect on people and why those things might be happening. Take some time right now and try our bonus claim. I'm not going to fill this in for you, but I'm confident that you can think about what is happening to the air pollution during the seasons. So in the air pollution in the seasons that are higher, so that was winter and summer, is higher than in the seasons spring and fall. And you can take some time to think about what might be causing that and fill in the blanks here. Good luck, folks. And next week, you're going to be creating a CER, a claim with evidence and reasoning from this app, from our data visualization tool here. That's something you're interested in. So it's going to be up to you next week, and you'll be able to explore all of these tabs, like this holidays one, which is pretty sweet, or look at some monthly data or some human impacts and try to make sense of that. Good luck, folks, and feel free to ask your teacher if you have questions.